Greetings. So we are going to tackle a question that is based on analytical geometry. So the question says here, in the diagram below, we have point P, which is 1:1, and then Q, which is 0:2, and then we have point R. And then they are saying these are the vertices of a triangle, and they are saying that PRQ is an angle theta. And then the x-intercept of PQ and PR are M and N. So we have M and N there as x-intercept. So now we were given also that the equations of sides of PR and QR are y is equal to -x plus 2 and x plus 3y plus 6 is equal to 0 respectively. And they're saying that T is the point on the x-axis is shown. So we have T now here, just a point there. So now the question says, the 3.1 here, it says determine the gradient of the line PQ, the gradient of the line PQ. So now we know to determine the gradient, we have this point P and Q. So those are the points where we want the gradient from. So first things, we are going to say now we know that the gradient is represented by M, which is y2 minus y1 all over x2 minus x1. Or we can write this as what? As Q, as y, as yq minus yp. And then we can also say all over all over xq minus xp. So it doesn't matter even if you can say yp minus yq divided by xp minus xq. So now I'm gonna use the first one there. And now our yq, we are given the equations, the coordinates of p, that is 1:1, and then we're given the coordinates of q, which is 0:2, -2. So now we have yq, so our m will be yq, which is -2, minus yp, and then our p is 1, and then divided by, now we have xq, and then our xq is 0 minus our xp, which is what? Which is 1. So that's going to give us -2 minus 1, which is -3, divided by -1, and then this gives us 3. So that is the gradient for that line there. And we know that it should be a positive because the gradient is slanting upwards towards the right. It's an increasing straight line. So the graph, the graph for the line PQ is an increasing one, increasing straight line graph, because now we can see that the gradient is positive. So that's what we get. So now the next question says prove that PQR is equal to 90 degrees. Prove that PQR is equal to 90 degrees, the angle PQR there. So our angle PQR, so that means it refers to the point or to the letter in the middle there. I'm just gonna mark it in red. So it represents this point here. We need to prove that this angle here is actually equal to 90 degrees. So to prove that that angle is equal to 90 degrees, the lines that join to make that angle, they should, their gradient should give us, the product of their gradient should give us a -1. That means if we find the gradient of PQ and then we find the gradient of QR, we multiply those gradients, they should give us a -1 in order for us to say that now they are perpendicular, is equal to 90 degrees. It will show us they are perpendicular. So now going to say now 3.2. Now for the angle to be 90 degrees, we need the product of what? Of M, which is the gradient of what? Of PQ. And then we multiply by the gradient of QR, the gradient of QR. So those two lines are the lines that are making the angle there. So now what we're gonna do is that we have already calculated the gradient of the line QP there, the line QP in the first question, or PQ, and then we need the gradient of the line QR. So now what we're gonna do, we are given now that our QR, the equation for QR, we're given X and then plus 3y plus 6 is equal to 0. So what we can do now, we can arrange the equation to say 3y is equal to negative x minus 6. When we're taking the x to the other side and the 6 to the other side, they become negative. So we're going to get y is equal to negative 1 over 3x and then minus 6 divided by 3. That is going to give us 2. And then that is the equation for the line there, which is QR. So there is equation of what? Of QR in standard form. So now we want to prove if those lines are they are perpendicular. So the gradient, we can say now that the gradient of what? Of QR is equal to negative 1 over 3. And then the gradient of PQ, which we have calculated before, was equal to what? Was equal to 3. So what we're gonna do now, we said MQR multiplied by MPQ is equal to negative 1 over 3 multiplied by 3, and this gives us 3 cancels 3, we get negative 1. Can say therefore QR is perpendicular to PQ, and therefore the angle, we can conclude now, since they are perpendicular, that means those lines are at 90 degrees. PQR is equal to 90 degrees. So we can say PQR is equal to 90 degrees. So we have proved that question there. So we're going to now 3.3. So now in 3.3, we are saying determine the coordinates. The question here says determine the coordinates of R. The coordinates of R. So where is our R now? Our R is this coordinate here. So is this coordinate here? We want those coordinates. So we can see that coordinates of R is where the line, this line, which is PQ, and this line, which is QR, meet. They intersect there. So if those two lines, they intersect, we have to equate them in order for us to get the X value. We have to equate the Y values. So now we know the equation of those lines, that the first equation that we have for PQ is y is equal to negative x plus 2. So we have y equal to negative x plus 2. And then the second equation is y is equal to the one we just determined here. So this graph, this is the equation that we're gonna use, is y is equal to negative 1 over 3x minus 2. That's negative 1 over 3x minus 2. So what we're gonna do now, we're gonna equate those graphs because they intersect. We're gonna say negative x plus 2 is equal to negative 1 over 3x minus 2. So now we're gonna have negative x, and then we're gonna get, we're taking this one to the other side to add the like terms, and then we're gonna get plus 1 over 3, and then that's 1 over 3x is equal to, the other side we have negative 2, and then we're gonna take that 2 to the other side to add the like terms, and then we're gonna get negative 2. So we're just gonna add those. We know that this negative 1, that should be negative 3 over 3, which give us negative 1. And then now negative 3 over 3 plus 1 over 3. Know that we're just going to have 1 minus 3 all over 3. X is equal to negative 4. That means here we're going to have negative 2 over 3 x, which is equal to negative 4. So now to make that the subject of the formula, we can multiply both sides by what? By negative 3 over 2. So here negative 3 over 2 will cancel on the other side, and then we'll be left with x is equal to, this side we're gonna have negative 4 multiplied by negative 3 over 2, which will be this, goes to 4 2 times, and then we know negative 2 times negative 3 will be equal to 6. So that is the equation that we get there. That's the x value that we get. And then now we're gonna need to find the y value. We can use either this equation or we use that equation. We should get the same answer. So what we're gonna do now, we're gonna say y is equal to negative, in place of x, if you are using the negative x plus 2, in place of x, we're gonna say negative 6 plus 2, which give us negative 4. Or if we're using this equation here, we're going to say now y is equal to negative 1 over 3, and then we multiply that by 6 and then minus 2. Y should be 3 to 6, it goes negative 2 times, minus 2, we get negative 4. So use one of those equations, they should give us the same answer. So now that means the coordinates that we have there is 6 is 2, because we put y is to x, y is to x, which is 6 is to negative 4. So those were the coordinates of the point R. So those were the coordinates of point what? Point R. So is 6 is to negative 4. So we're just gonna put them here. That we have here 6 is to negative 4. And it makes sense that on the right side of the Cartesian plane, the x should be positive, and then going down below here, the y's should be negative. So we get a negative value and a positive value. That's how to check if we are correct. So what next? So the next question says, calculate the length of PR. Leave your answer in set form. So the length of what? Of PR. So that means they want this length there. And to find that length, we need to use, that is length of PR, that's 3.4, 3.4. So the length of PR now, we just need to use what? The distance formula. We know that the distance formula is square root of what? Is square root of x2 minus x1 squared. And then we're saying again, plus into x plus into y2 minus y1, and then we're saying squared there. So that should be the distance formula. And then now we're just going to substitute that with the square root now. And now our x, we can actually represent this by the values of the variables that we have. We can say in place of x2, we can say xp, and then minus here say xr, and then squared plus into y now, yp minus yr, and then squared. So what we can do now, we're just substituting, and then our xp, we have 1 minus the x coordinate there is 1 in point P, minus xr, the x coordinate here is 6. So we're gonna say minus 6, and then we say squared. And then we say plus into, we have y there, which is what? In P, we have 1 minus, we have 4 here, minus will be positive, then we can say plus 4 squared, because we're gonna have something like 1 minus negative 4. So this will tend to be a plus. So now from there, the only thing that we have to do is just to simplify that. That is going to be the square root 1 minus 6 is 5. And then we have 5 squared there, plus 1 plus 4 is 5. And then we have 5 squared there. So what we're going to have now, we're going to have 5 squared plus 5 squared, and then that's going to be 25 plus 25. And then that's going to be the square root of 50. So that's what we have there. So we have answered the question. So the next question says now, determine the equation of the circle passing through P, Q, and R in the form x minus a, and then plus y into y minus b all squared is equal to r squared. So we need the equation of the circle there that is passing through P, Q, and R. So this circle must be passing, it must be passing through P, Q, and R. That means we have sort of a circle there that is passing like that. So to find that equation there, what we can do is that we know that if this circle is passing through these points like this, so we're going to need the diameter. So the diameter automatically, let me try to draw that better. So we're going to have a cycle there. Then this is a cycle that is passing through the coordinates, passing through these 3 coordinates. So now this line here, which is PR, will act as a diameter of the circle. That means we'll need to find that diameter, and then we divide it by 2 to find the radius. And to find that, we're going to need the distance formula. And then we know that the distance formula, we can say now the distance is equal to the root of into x2 minus x1 squared plus into y2 minus y1 squared. So now the coordinates that we have there, because we want the distance of the line, QR, PR, we need to find the coordinates of P. Then the coordinates of P is 1 is to 1. So we have P here, which is 1 is to 1. And then we have R, which is 6 is to -4. So those are the coordinates that we just determined. So now to find the distance there, we're going to say square root and then x. We can say now xp minus xr all squared plus into xr into y into yp minus yr and then squared. So we need to find that distance there. So since we already found, in fact, the distance from this question, we can actually use this distance because we found the distance of PR. If you remember, the first question 3.4 wanted that distance, which is square root 50. So now that means that distance, we already know that the distance PR is equal to the square root of 50. So now, we know that the radius will actually be the square root of 50 divided by 2. That's the radius. And then if we square both sides, we're going to get r squared is equal to 50 over 2, which is going to be 25. I mean 50 over 4, that should be 50 over 4. Because we square both sides like that, and then we square both sides, and then the square root will just be out on the numerator, then the below one will be 4. So we know that 50 divided by 2 is 25, and then 4 divided by 2 is 2, and then we know 25 is the same, 25 divided by 2 is the same as 12.5 there. So that is the radius that we have, or the r squared. So now after getting the r squared, we need, because the question was saying the form x minus a, so that should be in the form into x minus a squared plus into x minus b squared is equal to r squared. So we just need to find because the a and the b there, they represent the coordinates of the center. That means we need to find the midpoint there. The midpoint of PR, I believe that is PR the midpoint of PR. So that's going to be XP plus XR over 2, and then is 2, that is YP plus YR, and then that is divided by 2. So let's check. And then our XP, since we said these are our coordinates for PNR, so XP is 1 and XR is 6. So we have 1 plus 6 over 2 is 2. And then the Y's we have there. And then we have 1, and then we also have -4. That means we have 1 minus 4. So we have 1 minus 4 over 2. And then that's going to give us 6 plus 1. That's going to be 7 over 2. And then is to -3 over 2. So after getting those, we know the midpoint. That means now our equation can just say x minus, and then in place of a, we put 7 over 2, and then squared plus into x minus, that's plus 3 over 2, and then we say now squared, that's equal to 12.5, which is the radius that we found. So this should be the equation of that cycle there. So now let's go to another question. So now they were saying determine the equation of a tangent to the cycle passing through passing through PQ and R. PQ and R is the cycle. So they just want that that tangent that is passing through that cycle at a point P. So at point P in a form y is equal to mx plus c. So they want a tangent that is passing through this point. They want y is equal to mx plus c. So we want that formula there. What we know there, we know that in order for this to be tangent, this should form a perpendicular line between the diameter of the circle and that tangent. So the tangent line and the diameter should be perpendicular. And if the two lines are perpendicular, we know that, we actually know that, we change the color here. If they are perpendicular, we know that M1 multiplied by M2 should actually be -1. So if we go back there, we know the gradient of this. We know the gradient of this diameter here, because from this equation we can see that the gradient is what? It's negative. It's -1. The coefficient of x there is -1. So what we're going to do is that we're going to say now -1 multiplied by M2, and M2 is a tangent, should be -1, and then dividing by -1 both sides, we get the M tangent to be 1. So now the gradient of that tangent there should be 1, and then that tangent, we already said that it's a perpendicular to this line. They form 90 degrees here. So now in a form y is equal to mx plus c. So what we can do now, we know they want it in the form y is equal to mx plus c. And then what we can do is, we know y is equal to m. We know the value of m is 1. So we can just have x plus c. And then now we can use the coordinates of P, because they said is passing through point P. So we need to use those coordinates there, which is 1 is to 1. So to find the value of C. So what we're going to do, we're just going to put 1 here is equal to 1 plus C. And then taking that to the other side, 1 minus 1 is 0. So you're just going to get C is equal to 0. So that tells us that the equation will be y is equal to, and then we have m, which is 1 already. So that's 1x plus c, which is 0. So our gradient now, our final equation, that's y is equal to x. So we've answered that question there. So after that, they want what? They want to calculate the size. Then say calculate the size of angle theta. So to find the size of angle theta there, we need to find the so to find the angle theta there, we can there are many ways we can find it. So that angle of ours, angle theta, is this angle here, angle in R. So we can find that distance there, distance PQ. We can find that distance PQ, and then we find that distance QR. And then after getting those distances, since we know that this is a right angle triangle, we can use tangent to find the angle there. So since we already know that even this answer, I can actually simplify it. Let's see, square root 50 is the same as 5 root 2. It's still in sad form because the answer said sad form. So to find this angle there, we have let's see the distance that we're already having, that square root 50. They said calculate the length of PR. So we can actually maybe use this PR because we know that this line, it will still be correct either way. If we use this 5 root 2 here, which is the square root 50 we have found, which is the hypotenuse side of this right angle triangle. And then we can calculate also this side here. And then that length is what? Is PQ. If we can find that, we can will be able also to find the angle. So the P is 1:2, and then Q is 0:2. So we have P, which is 1:2, and 0:2, and then that is Q. So we need to find that distance, which will represent the opposite side of the circle there. So to do that, what we're gonna do, we can use distance formula again and say that PQ is equal to the square root of, say, XP minus XQ all squared plus into YP minus YQ all squared. And what we're going to do now, we say that we have what? We have the square root of what? Of XP, and then our XP is 1 minus 0 squared plus into 2 minus plus 2, because it's negative squared. And then that's going to be the square root. 1 minus 0 is 1, 1 squared is 1, plus 2 plus 2 is 4, 4 squared, that should be 16. And then that means we have the square root of 17 there. So according to that triangle of ours there, we have a triangle like this, and then this